everyone, welcome to Chemistry Made Easy class. This class basically we cover various topics in chemistry. So we implore you to please follow through as we consider various topics in chemistry. Today we want to talk about electronic configuration. This topic, no doubt, interests chemistry students. That is why we deem it fit to discuss this topic today. So just like I said, once again, the topic is electronic configuration of elements. Electronic configuration describes how the electrons of an element are arranged in their shell, subshell, or orbital. And in writing electronic configuration, you can make this possible in two different ways. One of them is what we can see here on the board, based on the structure of the atom. That is the use of main shell. Similarly, you can also achieve this when we make use of orbital electronic configuration in the form of SPDF. So we are going to disintegrate these two various forms on how we can make electronic configuration possible when we are asked questions related to this topic. So please, may you give us your attention so that as we explain each of them, you have full understanding, so that when you come across questions on this topic, you'll be able to tackle it. Now, before we start the explanation of these two forms, there are some things that we need to consider. One of them is, first of all, we want to ask ourselves, have I really seen the structure of an atom? So for those of us that have not really seen how an atom looks like, I will just use opportunity to show you people. Now take for example, this is an atom. This is an example of the structure of an atom. Now you know we said previously that if we want to make use of the first method, which is the structure of the atom, to get the electronic configuration of any given element, we need to consider how we need to number each of the shells, or each of the shell in this structure. Now we want to number the atom. We need to follow this procedure. You start from the first shell, which is K, L, M, N, O, P continuously. So this is how you can number an atom. So you start from the first shell, which is the K shell. Thereafter you move to the L shell. Thereafter to the M shell. So I want to number this atom using their shell. Take note, I said when you want to number an atom, you start from the first shell, and the first shell is the K shell, followed by the L shell. Also, take note, we want to use each of these shells to number the atom. You don't number the atom or the shell from outward to inward, but rather we number the atom from the nucleus outward. So in view of that, let's see how we are going to number the shell of this atom. Don't forget, we said we start from the K shell and we equally start from the nucleus. Now the first shell here is, going by this shell, is our K shell, followed by the L shell, and followed by the M shell. So you don't fill it in the opposite direction. You don't put K, L, M. It's wrong. You start from the nucleus atom. So depending on the structure of the atom, you will know how you are going to number the shell. Now let's see how we are going to use the explanation of this to understand the first method or form in which we can answer any problem relating to electronic configuration of elements. Don't forget, we said the first structure is based on the structure of the atom, that is the use of main shell. We have a lot of shell. This shell is continuous. It's continuous. That's why I put etc. there. So the first main shell, or the four main shells that we have are K, L, M, and N. But from this structure, we have just three shells. So like I said, it all depends on the structure of the atom you are given. Having said that, we also want to take note of this point too. Now, in each of these shells, we have to know the maximum number of electrons that can enter each of these shells. When we have this knowledge, it will be very easy for us to solve any problem relating to electronic configuration. Now, please, let's take note of this. For the K shell, the maximum number of electrons that can enter the K shell is 2 electrons. The next shell, which is the L shell, is 8 electrons. Take note, that is the maximum number of electrons that can enter the L shell. Then also for the M shell, the maximum number of electrons is also 8 electrons. Then for the N shell, we have 2 electrons. So these are the four main shells that we have: K, L, M, N. Though there are others, but just like I said, these are the four main shells. So having this knowledge of the maximum number of electrons that can enter each of these shells will help us to solve any problem relating to electronic configuration. Now, with the knowledge of this, we want to take an example. Please, let's consider this example. Okay, now let's consider this example. The question says, what is the electronic configuration of sodium? Take note, if you look at this question, I had to put the symbol just for us to understand, which means it's very important that as a chemistry student, you need to know the symbol of each of the elements in the periodic table. So I just use this as an example for those people that doesn't know the symbol for sodium, which is Na. Now let's see how we are going to use the use of main shell to solve this problem. Now remember, going by the principle that I gave previously, I said the maximum number of electrons that can enter the K shell is 2. The maximum number of electrons that can enter the L shell is 8, M is 8, and the N shell is 2. So the first thing you do is to first of all write out the symbol of the elements. Then also take notes. As a chemistry student, it's very important that you know the atomic number of any element that you are given. So for this element, which is sodium, the atomic number is 11. So please, when you are writing the symbol like this, take notes. Don't write the symbol like this, and you now put the atomic number here. It's wrong. You write it the way I wrote mine. And now let's see how we can use this method to solve this. Now we said the K shell has a maximum number of 2 electrons. The L shell has a maximum of 8 electrons. 8 electrons, and the M shell has a maximum of 8 electrons, and the N shell has 2 electrons. Now, how do you know the number of shell that you are going to apply for this? The first thing you do is to sum the number of electrons. When you sum them and you have this number, that determines the number of shell you are going to use to make up this element. For example, what I'm saying is this: K has 2 electrons, L has 8 electrons. When you sum these two together, 2 plus 8 will give us how many? Which is 10. Now, how many number of electrons is required to make these elements? 11. To make the atomic number 11 is remaining 1. So, which means we are going to make use of the K shell, the L shell, and the M shell. But in this M shell, we are not going to make use of 8. Taking, we said the maximum number of electrons that can enter this shell is 8. So which means we can have any number below 8. And we said for this element, we need to have 11, which is 2 plus 8 is 10, plus 1. So which means we are picking 1 from here to make it 11. In that case, we'll now write it out like this. K shell is 2, L shell is 8, and the M shell is equal to 1. Now when we check the number of shells that we have here, we have 1, 2, 3. The reason why I'm saying this is we want to draw the structure of this, the structure of this atom. Now we are going to make use of these 3 main shells, 1, 2, 3, which is K, L, M. Now we start with the first shell. This is the K shell, followed by the L shell, L shell, then finally followed by the M shell. Having done that, we want to fill each of these shells with their electrons. Now we are starting with the first shell, which is the K shell. The maximum number of electrons that the K shell has is what? Is 2. So I'm using this to represent my electron. Then for the L shell, we have 8. So it's going to be 1, 2, 3, 4, 5, 6, 7, and finally 8. Then for the last shell, which is the M shell, we have just 1 electron. You can fix that anywhere of your choice. So with this, we have put an answer to this question. What is the electronic configuration of sodium? So the answer to this is what we are seeing on the board. Take note, this method that we applied is the first method, which is the structure of the atom. That is the use of main shell. Though I said the main shell we have are K, L, M, N. But from the element that we are given in the question, it is sodium. And sodium has just 3 shells. So that is why we did not make use of the N shell. So that is for that. We want to consider the second method in which we can solve problems relating to electronic configuration of elements. Don't forget, we said the second method or form is orbital electronic configuration in the form of SPDF. Now, when we are talking about orbital is a volume of space where there is a probability of finding an electron. And when we are making use of the